Welcome to Section 8 of the FP Complete Rust for Beginners course. Today we're going to be doing an overview of error handling. Error handling is a complicated topic, not just in Rust, in most programming languages. There are many aspects to it. We are not going to be getting into all of the details. This is going to be a surface level review of the basic functionality in Rust, what's built into the language, as well as some of the commonly used crates in order to make things a little bit nicer or a little bit easier to work with. There's much more we could go into, much more around best practices that teams can work with. The idea here is to give you enough of a launching board to be able to understand code that's out there and to figure out what you want your best practices to look like. Let's start off with bad, tedious, error-prone error handling in Rust. I'm going to go ahead and copy this code over. All right. So what we're going to be doing in this example is we're going to be opening up a file, input.txt, and then that open is going to return a result. This is the basis of all good error handling in Rust. The result type can either give you an OK, in this case it'll give you back a file, or it can give you an error. Usually each module in a crate, in a library, maybe a crate overall, will define its own kind of error type. So in this case we're looking at the error that comes from the standard crate, the std crate, inside IO, so std IO error. Now that we've got a result, we actually want to work with the file inside of it. And the simplest way to do this, the most direct, obvious way to do this at least, is to explicitly pattern match using the match expression. So we're going to match on this file. If it's an error, we're going to go ahead and print out an error message, and then we're going to abort the program. If it's okay, we now have access to that file. Now I'm going to go ahead and call the method read to string to read all of the contents of that file into a string in memory. And again, we get back another result, this time either giving us the size of the payload or another one of those errors. And now I'm going to match yet again print out an error message if it fails, and in the OK case, now I'm going to print out the actual string. Now all of this works. There's nothing inherently wrong with this, but it definitely feels tedious. We can improve this slightly by going ahead and switching our code to using return. So I'll go ahead and make this change in front of you. Return allows us to short circuit, and we are also going to be leveraging the fact that in Rust, you can return certain values directly from main. Up until now, we've really only looked at unit coming out of the main function. But you can return a few other things as well, and one of them is a result. As long as the OK case is a unit, and as long as the error case implements the debug trait. That way, there's some way for the system to figure out how to display the error that was generated. So now let's go ahead and see how we can rewrite this. Instead of printing out the error here, I'm instead going to return error E. Okay, so now we've short-circuited, we've exited the function. We can get rid of this. Instead of nesting more deeply, like we're doing right here, which works, instead of doing that, what we're going to do instead is let mute file equal, and now the match expression. In the case of an OK, we're simply going to return that out of the match. And now I can remove this wrapping, reduce two levels, I missed one of the close braces, and now I can simply reduce the indentation. This already makes the code significantly easier to read. We can see that we're doing our error handling here, and then we're done. The error handling has been taken care of. We're going to return the error. There is a little bit of a problem here. Previously, as you can see here with this error message, we actually provide a little bit of context to explain what kind of an error was occurring or what we were doing when the error occurred. We no longer have that up here. We're simply returning the std IO error, which doesn't give as much information as we would like. We will get back to how to solve that nicely. But let's continue with this. Again, we did let res equal file read to string, and then we did the matching again. But we're going to do the exact same thing that we did previously. We don't care about the size, so let size equal size underscore with the underscore at the front to avoid a warning. And instead of printing the error message, we're simply going to do return error E. And here in the OK case, we'll go ahead and return the size out. semicolon. Now we're able to print the string, but we still have an error message. We can get rid of this import to avoid that warning, but we still have an error message at the end. Notice that we are trying to return a result, but the reality is this last expression we've got, this last statement is a statement, therefore it returns a unit. Instead, we need to return an OK of unit. And this is a common kind of flow that you're going to end up seeing quite a bit in Rust. You do a whole bunch of steps, each one of the intermediate steps may fail, and eventually you get to the end and you say, great, everything went fine, I'm going to return an OK unit to say that there were no problems. Great. Okay. This is nicer, but it's still tedious. The next thing we're going to see is the try operator, this question mark operator. And this is really a huge innovation in ergonomics in Rust. What we have here, this pattern, is very common. We match on a result. If we got an error, we wrap it back up in an error, and then we return it. We short circuit the function. Otherwise, we evaluate to that expression and stick it into a variable. This happens all the time. It's so common that this can be replaced with that bit of code. These two things are identical. And in fact, it's so common to do this that you don't typically have line 5 followed by line 6. Instead, you can just combine the two of them together. We're going to, put on a type annotation. So let me file, put a question mark, and that goes away. And now we've collapsed all of that error handling code down to one line with the question mark. We still have the same problem we had before about no context. We don't really know what we were trying to do when this error was generated. We'll get to that later. But this is definitely a nice thing to see. Question mark can be put at the end of any expression that evaluates to result or a few other things like option. This will go ahead and perform all of that short-circuiting logic for us. We can do the exact same thing here as well. Let size equal question mark collapse. Not only did this make our code significantly shorter, it's much easier to read, much easier to understand. This is better code overall, and this is very close to best practices in Rust. But let's go a little bit deeper. Generally speaking, the Rust community likes to have explicit errors listed at the type level. This is similar to checked exceptions that you would have in languages like Java. We like to be able to say something failed for one of these 5 reasons. And the straightforward way of implementing that is via an enum. So I'm going to go ahead and copy over this code so you don't have to watch me type nearly as much. What we're going to do is we're going to define our own custom error type as an enum. And in our program, there are 2 different things that can fail. Either we weren't able to open the file, or we failed while we were trying to read to string. So I have those 2 different cases as 2 different variants. When I'm trying to open the file, it turns out that this underline stdio error doesn't provide us the name of the file that it's trying to open, which can be very difficult, make debugging very difficult. So I've gone ahead and I've included both that and the source, the original error message, error value, as fields for that enum variant. For read to string, we don't actually need that. Theoretically, you could include the file name here as well, but I didn't in this case. We derive debug, since anytime you want to return a result from main, the error case has to have a debug implementation. And as a little nicety, I've defined a new type alias for result to say if you leave off the error type parameter, it's automatically going to fill it in with the error from this module. Now down here, function main is going to return a result of unit, which is exactly the same thing as a result of unit or error because of the way that this type alias is set up. This is where the code gets interesting. Instead of simply being able to put in a question mark, I need to be able to wrap up the underlying stdio error inside our custom error type. The common way to do this is to use the map error method of result. So I've done map error, I get back the underlying stdio error, and now I'm able to construct, using normal enum expressions, I'm able to construct this open file error. I provide the file name and I provide the source. And then at the end of this, I'm able to put in the question mark operator so that it's able to return immediately. It's able to return the error value immediately if it exists. The exact same thing occurs down here with the size case. So this is nice. It's a little tedious though. Having to write out these constructors manually is a bit of a pain. And there are a few other pain points that end up popping up around this, which we'll see some of the libraries that help minimize this. Right now, at this point, this would definitely count as best practices in Rust for error handling. If you never went any farther than this, you'd be golden. But there are some crates available that make life a little bit nicer, so let's see those. One of these is snafu. So I'm going to go ahead and pop up in my cargo.toml. In this case, I'd already set up snafu as a dependency. And let's go ahead and make the transition. Snafu is going to help us by making it a little bit easier to construct these values and to display them nicely. So instead of derive debug, I'm going to be able to do, that's not the version of the code that I want. Instead of derive debug, I'm going to derive snafu. By deriving snafu, it's going to create a few different helper types that we're going to use, and it's going to create a display implementation. We have to help it out with the display implementation though. I'm going to say with an attribute, display snafu, could not open file, blank, and then provide the reason. And what I'm going to fill in for these is file name, just file name and source. And I'm going to do the same thing down here. Snafu display could not read to string. Realize I'm using slightly different values than what exists in the slide, but that's okay. And now I'm going to modify, sorry, I shouldn't say 0 there. I'm going to modify this so that the field name is source. And snafu treats these fields named source specially and is able to handle some issues around backtracing, a few other things for us. We don't have the debug implementation, so we have to provide that ourselves. This is a little bit of a pain point as far as I'm concerned. The fact that we have this really nice display trait, but we end up using the debug trait for the output from main. So I'm just going to go ahead and provide one of these standard implementations. And I can't talk and type at the same time. And now we're just going to go ahead and reuse from display the fnt method. Okay. Now that we have that in place, let's go ahead and modify what's going on down here. Previously we used map error. That actually for the most part still works, but snafu provides us with some helpers. So instead of calling .map error, I'm going to call .context. In fact, I'm going to call .with context to say I'm going to give you a function which is going to generate a value here which can be used. I'm going to use open file. This looks a little tricky at first, and I'll explain why. Actually, that's not even necessary. You can just say file name. What we're doing here is we are mapping, with context, again, maps over the error case that comes back from here. However, it's going to automatically insert the source error at the appropriate place. And this open file is not exactly the same thing as what you see here. Open file is a struct, which ends up staying inside our module, and is a helper for being able to write shorter code in this case. Down here, we're going to go ahead and read the string, and we're going to do the exact same thing. This time we're going to call .context, and we are going to provide it read a string. Is that right? Let me go ahead and have a cheat. No, that is supposed to be right. Expected a use has found a result. Oh, right, because I forgot to stick the question mark at the end. And that's it. The code isn't much shorter, but we get much nicer error messages and much easier to manage error messages. And again, There's some more advanced capabilities here around backtracing, so that if you're using this deep inside a program, instead of a tiny trivial application, you get a lot more context around how things were called. Another approach that I want to mention is the from trait approach. I didn't give you all the details of how the question mark operator, the try operator, works. It doesn't simply return a value. It also uses the from trait to convert from one error type into another error type. And the purpose of this is to make it easy to deal with errors that come from multiple different crates that may all be using a different error representation, and combine them all together into one error type. So I'm just going to go ahead and copy paste all of this over. A big downside of this from approach is it doesn't force you to provide any kind of context. And therefore it can be very difficult, again, with this file open case. It's not going to provide any information on why the file failed to open. Let's go ahead and look at this. We've got an enum, and I've made up a new error case just to demonstrate the differences here. This error case is an empty file. We're going to decide that this program should have an error if input.txt has no content in it. And otherwise, we're going to treat all I/O errors as the same. We provide this implementation of from to say that the way you convert from an I/O error into our local error type is by wrapping it up in the I/O error variant. And now, down here, we don't call map error, we don't call context, we don't call with context, we just stick the question mark at the end. And it still ends up converting into our local error type. This is very convenient, but again, you lose out on the ability to capture context. Another library which can be very pleasant to work with is called anyhow, which I didn't yet add as a dependency. Anyhow takes a different approach. Anyhow allows you to have what's called a dynamic trait object. A trait object will allow you to provide basically any type, and it will only access them via the trait implementation. This can be useful, this can be nice to work with, and you don't have to put in nearly as much effort into defining nice domain errors. This kind of code goes away completely. The downside is that you're never forced to give context, and a caller of your functions doesn't know exactly which way things can fail. Whether that's a real problem depends on your case, but there's definitely a trade-off going on here. So let's see how this works. Again, like with snafu, we have helper methods like with context. So we're going to say here, format opening file. And again, we just stick the question mark at the end, and that works. Down here, we are doing the same thing, and we'll say context, reading to string. And finally, this final error case, we are going to, instead of saying if it's empty, return an error. There's a helper macro provided called ensure. So we want to ensure that S isn't empty. But if it is empty, then we're going to return the error message, file is empty. And anyhow automatically is able to convert this string into some kind, oh sorry, that's supposed to be S, is automatically able to convert this this string into an anyhow value, an anyhow error value. So this is nice, this is convenient. If you're talking about the difference between simply unwrapping all your results and causing panics, or anyhow, you should definitely go for anyhow. Anyhow isn't much more code, and it is much better error handling. Panics are something to be avoided. Anyhow is much more explicit. If you're talking about the difference between anyhow versus snafu versus this error and snafu would be fairly good competitors for each other. At that point, you really have to make a value judgment. How much do you care about the explicitness versus the cost of maintaining those error types? And it really depends on what kind of thing you're building. The general logic would be use something like snafu or this error if you are going to be writing a library, and use anyhow if you're going to be writing an application. But even at the application level, you could definitely make an argument that you should pretty strongly consider using something like snafu or this error instead. So getting off of the library topic, another aspect of error handling pops up when you want to start dealing with errors or streams of errors. And an example of this comes up when you want to look at all of the lines in a file. So in this program, we're going to open up src main. I'm using anyhow to handle all of the error cases. I'm going to wrap up my file inside of buffreader. Buffreader now allows us to call a method called lines. And lines is an iterator, or gives us back an iterator, which allows us to iterate over the individual lines in a file. The problem is that each one of those lines might be an error. And so a common thing to do is to start off these for loops, like you see right here, and unwrap via the question mark operator, unwrap that result, return any errors that might occur, and then shadow the original variable. So this let line equals line. I'll take off the context bit just to make it very clear. This thing right here is the core concept, that you have a stream of results, and now you do let line equals line question mark. And this kind of thing pops up a lot. Even when you get into async with Tokyo, you start dealing with streams, the same kind of thing applies over there as well. So, conclusion of this topic. The question mark operator is awesome. It is the core of good error handling in Rust. It is used all over the place. More syntax, I just happen to mention Tokyo and async. The async await syntax was specifically designed to work very nicely together with this question mark operator. You're going to see this all over the place. Result is the core type that is going to be used almost everywhere for marking that a function may have some kind of an error, may fail in some way. You can define your error types yourself, but it is very common and probably, it's actually a wonderful idea to use some kind of a helper library like snafu or this error to define your own error types. You need to make a judgment call how explicit you want to be about your failure cases between snafu or this error versus something like anyhow or other kind of trait object approaches. And just a plea, not a Rust specific one, just a general one, please make sure you include context for your errors. It is very common to be running some kind of production code and you get an error, file doesn't exist. Well, what file? Why were you trying to read it? What's going on? You don't want to be the operator sitting around at 2 a.m. trying to deal with that error message. So anything you can do along the way to provide additional context is wonderful. All right, that's it. Thanks.